Lesson 4 has to deal with kind of classifying numbers, rational versus irrational. Kind of talked about this a little bit last year. Rational numbers are numbers that can be written as fractions or decimals. Now, that doesn't mean they have to be fractions or decimals. It just means they can be written like that. So, for example, 16 over 4 would be rational because that ends up equaling 4. 3/4 is 0.75. Okay. Other rational numbers would be even like -5 because you can put a 1 under there so it can be written as a fraction. 2.3 would be a rational number because that's a decimal. So rational numbers include terminating. And if you don't know what that word means, that means to stop. And repeating. Just spell your best if you can't read this. So terminating, like decimals that stop, like this 2.3. My dogs. And then repeating, like 2.3 repeating. So the square roots of perfect squares, and you should know what that means by now, the ones that when you do it like square root of 16 end up a whole number. Those are all rational numbers. So the decimal stops or repeats. Okay, irrational numbers cannot be written in fraction form. So irrational numbers would include, just the opposite. They don't stop. I don't know what they're barking at. They don't stop and they don't repeat. They would also be the square roots that are non-perfect. So, for example, the square root of 17. A decimal that doesn't stop or repeat might look like 1.245, and then sometimes they put little dots. It'll go on your calculator. Obviously it has to end at the end of your calculator, but you can tell that there's no like repeating patterns, and it goes all the way to the end. Pi would be another irrational number. So we need to determine whether these are rational or irrational and then explain why. So -12, okay, that is irrational. And I just write the word that it stops. Okay, because it could be -12.0. It stops. Pi, you should know that's irrational. Okay, goes on forever. Goes on, no pattern. Because repeating decimals go on forever, but they have a pattern. Okay, 0.6. Rational. It stops. And you can pause the video if you want to try these on your own, but I'm just going to keep talking about them. 7/8. So, what do you think you have to do for that? You have to divide it and turn it into a decimal. And when you do, which I don't know exactly what it is right now, it might be I can't remember right now. Anyway, it is a rational. And remember, if you don't have a calculator, you would do 7 divided by 8. Okay, and then you add a decimal and a 0. I think it's 875. Yeah, I'm pretty sure it is. So it ends up stopping and it doesn't repeat. So that's what they mean by it can be written as a fraction. Okay, this one is going on forever. So that would be irrational. Goes on. And notice it's not a pattern, even though it's 1, 2, 3, 4, 5, 6. It's not like repeating. So, okay, 0.33 repeating. So obviously it repeats. The square root of 20. You should know that's not a perfect square root. There's nothing times itself that equals 20. So not perfect square root, I'll just do. -1.75, rational, because it stops. And this one is the opposite of the square root of 121, which we know is 11, negative 11. So that would be rational because it's a perfect square root. Okay, so on the back, it has some questions. It's the same type of problems, just written in, with story problems. So I want you to stop and try to solve those and see what you get. Okay, I'm going to go ahead and talk about the first two. This one would be irrational because 150 is not a perfect square. The next one, I went through those in row, like this one stops, repeats because it has a 9 on the bottom, so we know that would be 0.5 repeating. You can use your calculator and divide it if you need to. Perfect square, repeats, so this is a non-perfect square, so that would be the one that is not rational. Okay, he converted 5/11 to a decimal, and it was repeating. So does this mean that it's rational or irrational? That should have been rational because of its repeating. State whether the values are rational or irrational. This would be rational because it stops. And this one would be rational because of the repeating. But this one is going to be irrational because the dots mean it goes on forever with no pattern. And even though, like I said, it's 4, 5, 6, 7, that's not a pattern because it doesn't repeat. I mean, that might be a pattern, but it doesn't repeat. Okay, state whether the values are rational or irrational. So right away, you don't even need to find the answer to this because if this is not a perfect square, it's going to go on forever. So it doesn't even matter what the estimate is or anything. You can't even find the exact answer. Okay, on this one, we have underneath the square root is 30 plus 36, or 30 plus 6, which is then the square root of 36, which we know is 6. So that's going to be rational. On these, both of these are non-perfect squares, so that is going to be irrational because these are separated and these you do first underneath there. Okay, and give an example of an irrational number that is greater than 10. So an example could be the square root of 105 because that's going to be above 10. So basically, anything above the square root of 100. So you could do the square root of 101. So anything above 100. And this is another one where I would recommend doing the homework for.